You can sit here. You can sit here. That's fine. Go for it. Go for it. All right.
Sorry about that. I can't use that intro Python. And that's basically the summary where you can get access all the material for the coursework.
The website is the
It can be either or. I on the DNS I symlink, like not symlink, but I linked Christopher Cockmeyer to Chris Cockmeyer. Either or, it'll just automatically. So yeah, for anybody who needs to look at the summary page, that's where you would look, and that's for every single class. So if you come to like another lecture series, you would just look at that. Now, because typically I would, in most lectures, most classes, I would lecture for like about an hour and a half to 2 hours and show examples. Application classes are a little different. I wanted to try out more of an open framework where people can cooperate or pick a specific project and go through it. But because I still want to make sure people kind of understand what each project is, I will go through it.
You're live.
I'm live?
Yes.
Great. So to see what this class content is, we'll go to 4.intro to Python, the applications course. And I just added this a few seconds because I realized I didn't have a summary page, but here are the 3 applications and available code for each. The first one's kind of an interactive prompt. So, if you've ever worked with a terminal, it's kind of similar to a terminal, and you kind of develop one custom from, basic accepts only an exit code to more complicated kind of logic maps. The second one is setting up a basic web server. Now, when I say basic, I mean a one-line web server, and it's just showing you more like, I run one Python command. You get to write some HTML web pages, and then you can actually see how Python mediates that connection. So it takes the HTML file and throws it up so that a browser can see it. And then the third one is kind of what I call my toughest class. So this is the harder difficulty. It's processing data in a file. So you open up a file in data, open up a file. In this case, it's one of 3 major classical literature works. And then you go through this process of, replacing certain words, doing word counts. This last one is more kind of a challenge project. So you will touch stuff that isn't in the previous lectures. So if you don't want to really go out of the bounds or just want more basic practice, I would recommend applications 1 and 2. And then for application 3, that's going to be a little bit tougher. And there's even a tiny section called advanced. And you'll see a warning in the lecture notes. And there's a small section on that where you use these 2 libraries. One is called the operating system library, and the other one's called the system library. And you interact with the process and the actual file system. Yep.
So we're going to go over application 1 and 2 together for the lecture.
So what I'll end up doing is I'll go through all of these, but I'm not going to actually do the code. But I will go through the steps so that you guys can figure out which one you want to work on. And then I'll be around, and if people want help or they need a hint on like what lecture to look in. And then a little bit about kind of the style of the class. It builds on previous lectures. You start with a very simple step. So step 1 will be a very basic thing, and then you're going to build on it iteratively. You might have to go back a step or 2 to go ahead. So maybe step 5's code isn't necessarily perfect for step 7, so you might have to go to step 4. So it doesn't have to be linear, but it is pretty linear in terms of steps. And then we'll talk a little bit about how source control works. So a lot of software developers use something called source control, and it's just kind of a way of automating saving code and being able to go back in time and look at previous versions of code. So we'll talk about GitHub. GitHub's where I keep the source code. So if you go on my chriskottmeyer.com, you click the code link, it will go to GitHub. And this is just like a very high level view of what GitHub is kind of doing. It takes a copy of the code. So typically you'll have some code, you'll take a copy of it. Both copies kind of exist in parallel. You make changes to the copy you're working on. Then you might submit it to your team. Typically how developers work, people will review that code and look at it and make comments, and they'll make more changes. And then once everybody is kind of set and done with the code, with that specific, what we call a branch, they end up merging it back into the master code. And usually we call this line here production, if you've ever heard the term production. And this one's usually kind of more like a development branch. So just very high level view of how software engineers would kind of go through modifying code and then bringing it back into the production models. Then a little bit about how to think like a developer. So I suggest while you're actually working on these problems, write a few lines of code at a time, run it, make sure it works. If you get an error while running it, you fix it, or if you have what's called more of a semantic error where you run a program but you get a result that isn't what you expect, you can work on the program by printing out variables or printing out sections of the code and then just seeing where the error is and fixing it. Once you've fixed it, you kind of want to save it. And since we don't use source control in the class, you might want to save it as another file. So if you've gotten an extensive part of the program done, maybe a step in this program, you might want to save a version of that. And that way what happens is, let's say you're on step 5 and you write some code and you absolutely hate it, you can always revert back to a previous version. That's just a little bit of a diagram real quick. So, develop code, you modify your code, make fixes, and then once you have the fixes, you commit it back in. And then this is just talking a little bit about versions, acting as save points. You have many different file versions, you can always go back and take a copy and then modify it. And then a little bit more. So one thing I suggest is I would suggest, you choose a specific application, work on it. If you get stuck on an application, so you get to step 6 and you get frustrated and you're like, oh, this is getting really annoying, it's totally fine to go switch and try another application out. And then if you get stuck on all 3 applications or you're really determined to finish one off, I suggest, if you get stuck, go to previous lectures or go online and look at the concept that you're having a problem with and just kind of keep working on it. And that's kind of my suggestion on how you would learn this stuff is, pick an application, get as far as you can. If you get it complete, great, blog about it. If not, keep working at it. And then if you get frustrated, just move on temporarily. So here's the 3 applications, and I'll go through the kind of high-level steps. So the first application is, I call it more of a chatbot, but it's really more of an interactive prompt. So what you'll start with is just a very simple thing that accepts user input. And then if you type exit or quit, it should exit out. And then we build on that by having this kind of chatbot ask you questions, and then you have unique answers to it. When you advance it a little further, you start asking multiple questions. You might ask a question multiple times. And then the last portion, we start having more of this logic map type situation happening. So you might have one question leading to another question leading to something else, and then finally one answer to a question might exit the program. So this whole process, this type of cool little chat program that you build is a 10-step process. You start with the very simple, and then as you do more steps, you end up building something quite complicated. And then a great example is, I don't know, anybody watch The Big Bang Theory? So if you ever watch The Big Bang Theory, he has this really crazy chart he draws on one of the episodes where he talks about, how do you create a friendship? And he goes through this whole logic loop, and he even has this type of while loop type construct happening in the background. So in a very similar vein, if you decide to do this application, you kind of go through the hoops, and in the ending, you can create the equivalent of a friendship map if you want to, or a friendship algorithm. And then just the steps real quick. So first step would be an interactive prompt with exit. Steps 2 and 3 is you get the prompt to ask you a question. 4 and 5 is you have the prompt ask a question multiple times. Again, multiple times. Step 7 is you have a question, back and forth relationship. So your prompt will ask you one question and then ask another question, and then it will go back to the first question. And that's so you can start seeing how to link questions with each other. And the last one is you kind of have the chatbot have a full conversation. So my recommendation is you create 6 unique questions, and then you figure out how to link the questions, and then have 2 of those questions. If you answer it specifically, it exits out the program. The example for this is actually a doctor. So I have my example program is an interaction between a doctor and a patient. And basically what it ends up happening is the doctor says, "Do you feel sick?" And you literally have to tell the doctor, "Yes, I'm perfectly fine." And then it will exit out. Or otherwise you end up going down. You end up having to pay $500 to get a dose of medicine. So that's like a fun little, if you get to that last step, it's a kind of fun little interactive program. You can make your own version. You can make a dungeon crawler or like a conversation that you'd have on a bus or something like that. You can go crazy. Then you can create your own product, which is kind of what I got at. Number 2 is a little bit different. So each of these applications are supposed to be slightly different and introduce new concepts. Application 2 is a web server, and there's very little Python programming here. Basically, you have this one-liner that creates a Python server, and then within that directory, you have like web pages, and then it just shows you how to serve those web pages. So you can kind of think of this as a very, this is more a tutorial on setting up a development web server and then learning how web pages work. And then this is just, it teaches you how to set up the web page. You make your first web page. You also have Cloud I/O. There would be your first web page would be Hello World, and each step goes a little further. So it introduces headers, and then you might end up with something like that. I'll just show you the web pages, and then if you're interested, you can just tackle it. Then we add color to it, and then after color, we add some background and talk about generalizing style. And then the last one is not something to code. This is more like you download the code itself, and it does there's this framework called Bootstrap online, and I just show you how you can use this very simple web development one-liner to host a Bootstrap instance. So don't code this. It's like about 1,000+ lines of code, but it just shows you that this is actually what a web server is doing under the cover. You can see a more professional model running. And then the last one, just to prove that this is actually a hard project versus the other two. The other 2 projects take 30 slides. The third one takes 30 slides by itself. So there's as much material in the third one as the first 2. This one, kind of more of a data analyst task. So the first one was more interactive prompt application style. The second one was how does a web server work. Third one talks about kind of more like an ETL process. So you extract data, you do some transformations on the data, and then you might load it into a file so that there's a summary. So this deals a lot with kind of file handling. And this is a good explanation of kind of what you would do in this project. You might have data in a file. You feed it into Python. Python transforms that data. Then that transformation, which tends to be things like word count summaries, then gets spewed back into this other data set, so another file. And a bit about what will be covered. We talk about how to read a file, how to write to a file, how to append. So there are different ways to manipulate files. For reading files, we talk about how do you actually read a file and how do you get the contents out. So the first application is just that. We talk a little, and this is why this is more of a stretch class. Application 3 is more of a stretch class, because we talk about these things called string methods. So you can take a string and you can modify it. So in this case, we talk about how you can lowercase a string, or you could replace certain contents. That's just going over that. Then we talk about how you can take a file and you can read it line by line. So usually when you read a file, you can read the entire contents as one and then just assign it to a variable. You can also go through the file line by line by line and then just do manipulation per line or do more custom logic. And then we talk about a find pattern where you can find certain words in text. So that's what that does. We introduce something called a split function, which gives you words, so you can look at word analysis. So you'll have kind of a bucket of words. And we introduce, just as a very convenient way of counting, there's something called a counter. And what counter does is you can feed it this bucket of words, and it does the counting for you. And then there's a lot of really cool methods associated with counter. So you can look at like the top 10 words, top 100 words, and just print it out, and you'll actually see, the 3 books for this, for example, are, Alice in Wonderland is like one of the books. So you'd suck in all of Alice in Wonderlands and be able to say, what are the top 100 words in Alice in Wonderland? So that's kind of what it gets a little more complicated. We actually, one step is you have to combine all 3 books. So there's 3 full books and you'll have to combine it and then do the word count. Then we talk about writing files. So you'll have to write the summary. So it's the same line by line analysis, but you'll end up writing a summary text. And then we get to this more advanced section. So then more advanced section, we introduce 2 kind of very high level libraries where you can interact with the system. And I suggest, if you're not comfortable with Python, to avoid this. But if you're really looking for a fight and you find everything else easy, this is probably a kind of interesting little section you can tackle. In the advanced tutorial, it goes through 2 libraries, sys and os. And the basic idea is sys allows you, when you're typing Python file name, you can add extra options that will get ingested by Python. So I can say Python process book and then say Kafka.book or Kafka.data. And it will just take that Kafka book, or I could replace it with Alice.data and it'd be the Alice in Wonderland analysis. So this allows you to, on the command line, instead of just in the text, manipulate or add extra value. And then this is, the last one is parameterized process. This one is definitely a significantly higher hurdle. But this uses the operating systems library. And what you do is you actually go through an entire directory. And if you see a single .data thing or .book file, then you can prompt the user, do you actually want to process this? And then once you process it, you can write a summary file. So that's a little bit harder, but you're basically manipulating an entire directory and looking at all the files in the directory, but within Python itself. And then the last little section is you can do all of this in Python, but there's actually a lot of ways to manipulate files within the actual terminal itself. So most of this is dedicated to file processing in Python, but you can actually go write things like cat, WC stands for word count, and grep for filtering, and all those kind of command line things can be used to manipulate files too. So if you don't want to do it in Python, there's always other options, and this is just showing you how to do it in the terminal. And that's basically it. So those will be the 3 applications, and then I'll just put up the application section. There we go. And so this is more of an open section. So if you want to work on a specific part of the lecture series, you can do that. If you want to, form teams and try to tackle one of the actual applications, I'm more than willing to sit down and kind of help people out. But this is kind of more of an open project so that people can kind of, if you need to catch up on the lectures, you can catch up on the lectures. If you want to really hone your skills, it kind of provides 3 different applications you can try. So anybody want to work on one of them?
Yeah.
Or do you guys prefer I go through one, or probably want to actually see it? Or?
Do it together. Do it together.
Yeah, or we could do one together if you want. I don't know how you guys would like to do it. Yeah, let's. I feel like maybe we can go through the easy one, just because I think that one's kind of more.
Yeah.
You can kind of play with it a little more. So for the easy one, just really quickly, we're going to use something called the Simple HTTP server, and it's a one-line web server that you can write on the terminal, and it starts a web server that's in the directory, and then you can put index HTML files there, and HTML files are just kind of like web pages, and it will actually service those web pages. So really quickly, I'll show you how to set it up. Oops, there we go. So if you have the class material, if you're, I'll do it on WebIO, the IO, CIO, C9, Cloud9. We'll delete. So I'll just create another workspace. Let's call it application app 1. And a lot of this lecture material, it's on lesson 0. It talks about setting up this C9IO. But it's just basically a website. You provide fill out some basic forms, and then it lets you host in a Linux environment in the cloud. And then you can just add my GitHub repository up here. So the innovators class, and press blank, which is an Ubuntu symbol. And you can create a workspace. It takes a little while.
So we copy the GitHub repository and.
So there's like a little segment
Yeah, the whole.
on the workstation. There's like a repository.
From, yeah.
Yeah.
from Git.
Yep. Let me I can look at it real quick.
Right. Yeah.
Yep. So you would just take the repository.
Right.
Yep.
Yep. This whole thing. Right.
I'm coming up with the phone. All of this stuff.
Yeah. Yep. Okay.
Does anybody else need help? Yep. I'll wait a few minutes just in case people need help getting into C9IO. Or alternatively, you can also just get the GitHub repo and then just run it on locally as well. So let's say once you've downloaded the code, you get into this class application 2. So we changed the directory to class 4, cd class 4 application 2. And once you press enter, you have all the files there. So we have indexes 1 through 6, which represent different websites. And then the vendor section is extra code that's used in index 6, which shouldn't be used as a project. That's more a It's just showcasing that it's actually a website. And then generally, since this is a web server, we have to run an independent process because the web server is going to sit there. It's going to look at the port, which is where the internet connection is coming into. It's going to pool it. And then when it finds a request from the web browser, it's going to look in and retrieve one of these 6 files here. I'll show you that in a second.
How did you get those files on your side?
So if you go to Cloud9,
Okay.
if you go to this GitHub repo,
So application 1 and then
yeah. So let me help you out.
So you get the URL for that.
Go to Innovator Class. Grab this entire URL right here, and then on your Cloud9, create a new environment.
okay.
Because you
Yeah.
just go back. One more back. Maybe I should go real quickly and I'll show you how to set it up. And then once you're on move, just copy paste that there. And then app name, description, just as usual. And I'll do it. And then once you start that, all the code will already be there. That's the idea behind it. So once you're in there, use your command line. You would go down cd into the application 2. Once you're there, you can go to the lecture slides real quick. And there is this, here we go. There is a code for Cloud9. And I'll go through it real quick so you guys can see it. The code here, once you've cd'd into the right folder, it's sudo, which is kind of like the administrative permission. You need administrative permission to run the web server over the internet. Python, which, that just runs Python, -m, and then it's simple, capital SIMPLE, HTTP, that's all caps, server, capital SERVER, and then space 8080. So I'll write the code up there so people can look at it real quick. So it's going to be, once you're in the directory, sudo Python -m, capital SIMPLE, HTTP, server at capital SERVER 8080. So you're going to go CD, CD, passport. So try the passport. Capital C. CD application 2. Okay, so now right back as
So, right, so, okay, so wait, I got here, so.
Okay, and then you type this.
Oh, okay,
Just type that. Sudo Python -n simple HTTP.
is that a capital S, doesn't matter?
Yep, capital S simple HTTP capital.
Yeah.
Capital S. I'll underline.
Simple
So this is capital, these three are capital. It's the Python libraries cap.
Yeah, well, let's try this one instead.
Oh, pseudo means
Python 3.
Lowercase?
Yep.
Oh, we do.
Oh, yeah.
And then
So my global spelling, pseudo is lowercase.
It's awesome.
You go to the browser and go to
So once you get into here, you can press enter and you'll get this little commentary in the background that says serving HTTP 0.0.0.0 port 8080. You guys get that? And HTTP is just the browser that is the protocol the web browser talks to. This next thing is the computer name. That's an IP address. And then the last part is the actual port. So what segment of the computer it talks to. And then let's say you actually want to see the web server in action. You can, if you click this window button real quick, you'll see a share button. And on the share button, there's this segment called application. If you click that and copy it, so you'll copy this. And then in a new tab, just like you are opening up a new website, which is what it is, you can just do -index HTML. And if you press enter, you click open app, and it will actually show you Hello World. So once you do that, if you open up a new terminal, we go, actually don't even open up a new terminal. If you want to see what code it's hosting, you can press index HTML in this little thing, and you see it says Hello World here. And then if you look at the actual web application on the right, it says Hello World there. Do you guys see that? And then if you want to look at the other files, you could. Yep.
Is it copy?
Yep.
This.
Okay, so you got it running there.
Yeah.
And then go to window.
Yeah. That's right. Then I put there. Application, right? And I would copy, and that's what I did. Yeah.
Just click on it.
Yeah.
Copy.
No, I'm not using
Yeah, and I copied it to Windows.
So I'm
Yeah.
using the
I copied it to Windows.
There you go.
Yeah.
And then if you go here, put your cursor there. Then slash. And then the index 2. Just click on
I got lost trying to find
and then you can index 3 or index 4.
So far, I don't know.
Yeah.
Oh, okay.
But these are.
And then if you want to look at the code, what you would do is look at the index files.
So you can get to, you go to.
So you go back there. To the outline. And then go down to So what it's doing is Python's running in this directory.
Yeah.
So when you type index HTML, just
Oh, yeah.
Oh, there's a link here that says code.
Well, I've seen a lot of people.
don't know if you know.
Yeah.
Because he's using a Mac. Maybe
Have working experience with clients.
the behavior is because I did the same thing.
Right.
I didn't even have to use
Yeah.
maybe the way was
Yeah, I don't think I created my own environment. Inside this inside yeah, inside of these are all the files. It's 30. So when you do S3,
inside somewhere else.
no, this is
So it takes this file and directly puts it on.
Maybe what we would do is you pull them.
So then, and then what you do is you come to create your own something, HTML, play with some of the contents in those emails, copy it over, and if you approve it, what happens? You should see a direct correspondence with what happens here, automatically translated to the page. Or you can just go to the index.
Which bus is that?
Add a bunch of
Two?
things.
Sorry. 4. Application 2.
How are you guys doing over here?
But we're just putting in
So that's a little different. So you see the 8080. I would get rid of the 8080 and don't run Suka, and it works.
But he's on Mac. So, if he's on Python.
Can you do Python 2.7?
Are we doing it on the cloud because we already have the HTML pages ready?
You can run it yourself if you want to.
No, but
That's
are we
what's
doing it on
the-
the cloud because we already have one?
Is that the push?
Yeah. That's just it makes it
For
easier. So I
application
have the
two?
class using Cloud9.
But the thing
Since
that
the
he's
beginning,
trying to
so
get
if you need
guys
help with
working on
Cloud9,
is getting the web server.
Right.
Which has nothing to
Just
do
by
with the source
itself.
code.
Oh, nothing. Oh.
That's after you get that running.
Oh. So is the Python web server? Is a
Yeah. So web
yeah.
server
is that written by him or is it Python?
is
Because
part,
it
I think it's part of the
So they
Python.
did-
Oh, got it.
Okay. Let me try over
I
on
thought he wrote that
2.7.
web server.
Oh, no.
So I'll just show you guys real quick, and then once the server's up, you guys can actually write HTML. Is this Windows?
It's sudo in front of it. There's another word in front of it.
But I'm using Windows.
Oh, you're using it.
Yeah, the Windows.
They work for version of Python.
2.7.
Okay.
Simple HTTP server. Python 2 Python is not recognized.
You sure it's Python 2, right?
Yeah.
You do like Python dash version. Just to make sure.
It says the Python's not.
Right, yeah.
It's not recognized. It's not in the tab.
You're inside.
And inside.
Because you're inside the terminal, inside the Visual Studio.
Right, yeah. But actually that's my prompts. They should almost send those prompts.
You might try using CMD or try to open an actual Windows shell or run CMD.
Or have.
Try this.
Is it really? No, Python is not recognized. I thought I installed it this morning. No, it sucks. You didn't have Python.
There's 2 settings.
Yes, I'm under Python prompt. It's 5714.
Yeah.
Oh, 2.7, okay.
We have
Yeah.
to simulate it. I mean, not simulate it. Not simulate it. Oh yeah, because we have to run it in the folder.
Okay, so you already, so how do you get in here?
Yeah, that's
I
gonna
just
serve.
opened the
So you have to
search
go
for my
to
Python, install it,
So you
open
need
the
to grab
Python
the code.
prompts.
I grabbed it.
Where,
You right click on that.
where is the? But you're not here. You're not on the desktop. That's the problem.
Okay, right click.
So if you go here, right, you exit out. That's the code.
Where is it?
If you do PWD,
File location.
you're in your bin right now. You gotta go to your desktop. And your CIC
Copy.
password,
Paste it there.
Alright, go back to your
application.
Control C or something. You're already in.
Yeah.
Oh, no, enter the keypad. Control or exit.
Application
Just
2.
exit automatically
Okay, go back over here.
to the
Yeah, CD
Now if you go to 8,000, it should work.
space quotation left, a double quotation, and paste. And a double quotation.
Now you can do index.
Okay, now I'll
And
try.
if you want to do really good, you need to
I'll
alias.
try Python dash M.
So alias that long string to Python 2.7, and then if you there dash index.
prompt.
And then 6 is really
Redirector.
really beautiful.
Your directory, DIR. Oh, that's good.
Yes,
Okay, go back over here. Right click on this one.
which one? This one?
I was
It's
trying
a
to,
shortcut.
yeah, I know. We're trying to find out where
Oh,
is Python.
where's Python? It should be in the yeah.
Oh,
C Python. Yeah.
Okay, now
So
go
we'll
back.
get back. So all right.
Let's see Python.
Yeah.
So
I was trying to do what you were
Okay, now try everything. Come in.
Right.
Recall.
So if I need terminal, I can
Python, that's simple HTTP server.
Okay, so that's, you have to
There you go.
put in the, how'd you put in there again?
Domain network.
Okay, now.
Yeah.
If you go to the browser and go to
I was trying to.
What port is it?
Oh,
this is
000.
you get one here,
Right.
right here.
On the command line. You go back.
Oh, sure, just down there. Yeah,
Oh,
yeah. Port 8000. Yeah. Port 8000.
Yeah, it's a different port than the. It's not that one.
Oh, no.
It's more of intuitive.
Yeah,
I didn't have to.
Oh, there is.
I don't think I pulled something. I don't think I pulled.
All right.
That's what.
So it's just saying,
If you want
All right.
to.
Yeah, so this is all I was.
oh, it's 8080, that's why.
Oh,
So the issue is,
more of like
see how there's no number.
You don't have to.
But it's
type it.
so
Yeah, this one is compliant.
That's
So
it's like the thing is
interesting.
other than data, yeah.
It's okay.
I'll get it.
So,
We're not.
I just want everybody to have like web server access, then they can actually write code and actually execute your code.
62. Interesting. That's not right. I have this phone. Interesting.
okay, but instead of localhost,
Let's make
Yeah, it's PyCharm. Yeah.
I just get you to run it on.
This is so got zero dot
This is the
zero.
community edition, which is free.
That's 0.1.
That you can download it.
So, and then,
If you want to
Now what I'm gonna go slowly.
Yeah. This is the- Server on 0.004. Oh, wait, so.
now I'm studying master in computer science. Graduated in May 2018.
Alright,
So now,
What's cool about this is that
this thing is web server.
Yeah, that lives
So
in
you
here.
see
It's just running on top
yeah.
of this.
So
And then when we actually
one subject that I'm learning now is yeah. So for that I'm using Python. I aside from now in Python
Run here.
go back to his code.
we have two
Do that, yeah,
applications.
copy.
I did that.
You have to get,
Yeah, my apologies.
okay, did you post it?
Yep.
Oh, go to that
So
direction.
all it does is you're
Oh, okay.
Where you pointed to.
Right here.
Yeah, so what that was doing is just like
So right there, innovation class.
now that we have it set up.
Okay, so you go into
basically locally it just simulates so it creates so what I just
Yeah, you can call it anything you want. That's conventional.
Go inside
locally.
I wouldn't serve.
application T.
So
This is like by
now
convention.
from here
to your local
to
But then I would do that, then go look at the first
Slash
slide.
if there are HTML files, so that
Yeah,
it
and
will
then
display,
Python.
and by default
Yeah,
it
go on the
takes index
server.
of HTML.
Hit that index
Yes,
and you'll see it.
By
That makes sense.
like
That makes sense now. All right.
Okay.
Thank you.
it just
So hopefully everybody got the web server to run. Okay, so my recommendation is if you're actually running the web server, you can create your own file and you could call it like your name, HTML. And then you could go through the lecture slides. So the first one we have just, you can put any type of like text into this file. So hello world, this is Chris. I'm in a HTML file.
We know what it is.
And if I save this, it says Chris HTML. It just has some text in it, right? But if you actually go down here and you go to this HTML page, and remember this last part is just the actual file name, right? It's just servicing the file. If I press enter, then you can see hello world, this is Chris, I'm an HTML file. It's just pure text that just sits on there. Now, the next section talks about what we call actual it's called markup language. So we can provide additional context to our content by adding these markup tags. So if you're looking on the screen, I have an H1 tag. So it's like these arrows and an H1 in it. And then we have to obviously say where it applies. So the H1 starts here. You have some text in the middle. And then the H2 with a slash in the end tells you where it ends. And then there's an H1 tag, H2, and H3 in this case. And then there's a P tag, which is a paragraph tag. And those actually represent file formatting. So if we went back to our original page, let's say I was writing up a resume, I put H1 in here. I could do Chris Kottmeyer being the resume title. Maybe H2 is achievements, so I could do something like work experience. And H1 is like the high level header. H2 is kind of a low level header. And then maybe the next one is volunteer experience. And maybe you'll have something else underneath here for H2. I don't know, skills. And then under skills, I might have in a paragraph tag, I might say Python, R, SQL, some other different content here. And then if you run Chris again, you'll see that it runs that content. So H1 is the Chris Kottmeyer I showed, then each H2 tag is some subheader of that. And Python, which is non-bolded at the bottom, my skill set is that paragraph tag is the very ending. And then you could look at this. This is kind of more the traditional way HTML document is done. So each HTML document has a head, which has some metadata. So when you go on a website, you sometimes see on the top tab, you'll see it say the website's name. So that's what the title is. When you see that, that's the title tag. And then you have the body, which is the content. And you can put your content in there. So I take my original example, let's say Chris HTML, and I could do something like this. I could go put a head tag in here, put a title in here, and then this would be Chris's website. And then I could put this in a body. And the body would just be my content. And this won't make any difference except instead of having this HTTPS thing up here, it's going to actually say Chris's website. You guys see the difference? So the header tag, the head tag tells you metadata about the website, and the body tag carries the payload, which is kind of the information. And then if we wanted to add color, that's number 4 is talking about color. So we could take this thing that's called an attribute. We could go to Chris HTML and then just copy paste it, and you'll see there's this thing called style equal to, and then you put in double quotes color blue, and we could change this to red, and it will just change the color of that header. Now you see that it has a red header. So what's cool about this is, you can go in and you can start building out web pages, and Python is actually servicing the web page under the covers. So if you're more interested about this topic in general, there's something called W3 Schools. And W3 Schools is really cool. So if you're interested in how to build web pages from scratch, this little awesome website you can learn the basic tags that we just talked about. There's introductions, different elements, colors, which I mentioned real quick, so you can look into the colors. And so you could just sit there, you run this server in the back end, and you can build you can learn web pages that way. And you're using Python to do all the servicing or the plum work for you. And then once you get a little more used to Python, then you can pick up things called web frameworks. And web frameworks let you serve multiple pages and have custom logic. You have things like, a user has to be logged in before they can do that. There's, I would say, 3 really popular frameworks you can utilize for building websites in Python. They're Flask, Bottle, and then Django. I don't know if any of you guys have heard of that. And the idea behind it is Bottle and Flask are called minimalist frameworks. So they give you, similar to this, they just give you bare bones ability to service HTML, and you can add different features. You need a database, you can add the database on top of it. If you need logins, you can add logins to it. You need to have content management, you can add content management. And the opposite extreme, you have something called Django, and Django kind of runs with everything on top within it. So it's like a top-down type framework. And there you have everything built in, and you kind of have to disable stuff. And then just to show, go through, I'm not going to write this because this will take a long time for me to write. I copy-pasted it. But this is just to show you a little bit more of a mature website. And it's being serviced by the same Python instance. This here is like a more mature thing. This is there's a framework for building web pages called Bootstrap, and basically how Bootstrap is kind of a framework to make things pretty and make things responsive, so they resize to your cell phone and things like that. And you can run it on this kind of development Python server. And just to kind of show you the HTML page for this is when you get a little more experience. you have that header page here. You have a lot of like extra data in here about the web page. And just like that, you have a body tag. And that body is that content payload. So that's all the content there. And then you might have additional code in the vendor. So there's certain extra code you can do to manipulate how the website looks like. And people download it, stick it in vendor. And Bootstrap and all these things are just extra code that lets you format things. Let's see, where am I?
Python's basically serving all the files that are in that folder.
Yep. So I'll just show you guys up there kind of, this is a very, very high level view of how it works. And simple HTTP server is used more as a kind of quick tool to service something. It's kind of more like a toolkit, but it's a great example of just how Python can serve web pages. So you have like a very simple model. And the way it works is, at least for a simple HTTP model, you have your directory with your folders, and then in that folder, you might have a set of files. Then you run your Python web server, right? And Python, there's a little connection to the internet, which happens over a port. And you as a person are kind of, you're on your web browser, you're not really paying attention. You put in HTTP, a domain which represents a computer, and then you give a pathway. And what it does is it takes your HTTP, this is very high level. You have something like chriskoffmeyer.com. And then you'll have maybe index.html, right? And when I provide that in my web browser, the first thing it does is it takes chriskoffmeyer.com and it converts that into an IP address. And I actually did this process, but chriskoffmeyer.com is an address I paid for. So I kind of own the rights and I can tell it what computer to sync the domain to. So my web browser talks to Google or some computer out there that gives me an IP address. I connect via HTTP, which is the protocol, to that port. My Python server then receives the connection. Then it does some kind of like programming logic, or it might just serve this a file. It then takes this and it looks for that file. And once it looks at that file, does all the rendering and stuff like that, then it sends that content back to the web browser. It's got a very high level view of what's happening. And then what Python is doing is, without having some kind of server there to mediate the connections from the internet, there's nothing listening to the port here. There's nothing sitting there saying, is there a page coming? So simple HTTP server, what it's doing is, it's acting as that kind of plugin where it's talking to, looking at this port for a connection. And once it gets that HTTP connection, that's when it does the servicing. So that's what Python is. You can kind of think of Flask and other kind of Flask, and there's a bunch of, it's a very complicated process. You can kind of think of a web server as kind of sitting in this niche. And then in our example specifically, it's handling the files itself. So once it connects to Python, it just got to find the specific file. And that's kind of how this works too, in a way. Do you guys feel comfortable with that? Or it's pretty, makes sense, right? And you guys can actually visually see the code too on an actual file format. So maybe another example we could do real quick. I can go over the chatbot problem if you guys want to. Chatbot's a little more interesting. It's kind of like an iterative application process. So you'll build like a a simple shell, and then you kind of build out on top of that a bunch of commands. So let's go Cloud9 IO. So if you guys are in Cloud9 again, instead of going to application 2, you can go to application 1. So class 4, application 1. And then application 1 has a bunch of Python files. I think that's a little more familiar for most people. And these are kind of interesting, so that you can run them as an example, and then you can work on them a little bit. But the first one is, has a little introduction saying, this is welcome to the chat parlor, part 1, what's the basic problem, and then the solutions on the bottom. This one, you just can't do anything other than exit out. So if you type anything here, it's like, Chris, hello, I don't react. There's nothing, no reaction there. The only thing it reacts to is exit, and it reacts to quit. And that's how I would start out the program, is you're just building a basic shell. So this is just the print statements. It's just printing an introduction to the program. And then all I'm doing is I have a while loop. So I'll do test1 test.py. I'm going to open this on the side. Man, I'm getting too many files over here. And, this one's like a very basic while loop. So we just do while true. And then we grab the user input. And then we might add a little prompt button like this. Now the user input is inside this user input variable. And then I have an exit command, so we could just do this as an if statement. So if user input equals exit, or user input equals quit, we could just break the loop. Then obviously we want to tell our user about that we're exiting. So we might write exit in all caps. And you have your basic while loop. It takes an input like in previous class. And then if it's exit or quit, it exits out. And then we can just run the test1 1.test. And we have that kind of interactive prompt just like the terminal, where it's just waiting for input. And then if we type exit, it exits. So that'd be our first side. And then next one we want to do is we want to talk about, adding a question. So the next project, we have Python 2 project. And it asks right off the bat, what is your name? And I can type Chris. Your name is Chris. And this one just keeps asking the same thing and responding. Later on, we'll just have it ask once and then just go to the normal terminal. But this is just more how would you get it to ask a question first. We can look at the code real quick. So all we do here is we change the input section to what is your name? And then we assign that input here, and then we can just print it out afterwards, right? So that's nothing too much more complicated. So if we took this code here, we could create a new file just to save it at that point. And we could do to_test.py. We start with a README file does not start well. We can just take our former shell and then we can iterate on it. And that's kind of how the development process works. You start with a simple concept and then you just iteratively improve it and you just test it and fix the bugs as it happens. So in this case, we just put what is your name? And then this is saved in some user input. So we can say after it tests if it's exit or quit, we can just put a print statement in here, and we can just put your name is and then %s, and then we just put the % user input. And just in an iterative manner, we've just kind of improved that program a little bit. So if we run that, hopefully it runs properly. If not, we just have to go fix it. So we do test 2. What is your name? Chris. Your name is Chris. So that worked out pretty well. And now let's say I had made a huge mistake and really modified the code. If I wanted to ever go back, I could just go Python 1 test, and I'd be back to the original code and could work on that if I wanted to. So that gets us past step 1. Step 2 is asking that. Modify the previous prompt, create a unique response, quit. Oh, so we need to modify the code so it just asks it once. So that's project 3. It should only ask it once. Just look at the code real quick. This one's really simple. All I do is I add a Q number, the question number. If it's the first time it goes through it, then it's just going to prompt me for my name. The second time I do it, it's going to just have the standard prompt.
Chris?
Yep.
The raw input function, is that like the basic function? Yes? You didn't create it yet. The raw input function.
Which one?
Like user input equals raw input.
Raw input. So what this is doing, we could do a little high-level overview. While loop tells it to go over the same code over and over and over again. Just continuously does it unless I type break. So break is right here, right? What it's doing is, sorry, the headlights are getting in my way. You have while true, that gets that continuous loop on, just like a terminal in a way. You just have it constantly looping, looking for keyboard input. Then if it is, in this specific logic, we want to ask the question only once. We can say if the question number is 1, then ask for the name. If it's anything else but the first time we go through this, we're going to just have triple arrows. So what user input does is when I'm typing on the keyboard, you have the prompt here. What is your name is the prompt. I put something in there. That's going to save it to whatever I type into the prompt is going to be saved as a string to user input. Does that make sense? Yeah. And then, if it's, this is just changing what the prompt says, basically. Then we test out if it's an exit command. So we take the user input. If it's quit or it's exit, that's going to be a true statement. And if it's true, then we exit and break out of the loop. And this break command, what it does is, once it hits that break command, it gets out of that endless loop and lets the computer end the program. And then if it's the first question, what we do is we print the name and then we increment here by 1. So the first time it goes through, it's just Q number 1. The next time it's Q number 2. The next time it's Q number 3. And since it only prompts on that first Q number, that's the only time it's going to prompt for my name. Does that make sense? Yeah. So raw input is just the keyboard input, and it's useful because it interrupts the loop and asks for the keyboard input before going forward further. And I'll just really quickly, we can take the second one, and we can really quickly show how I turned it into this one. And I might have to do a little bit of a look-see because I don't have it on the top of my mind constantly. But we do 3 test.py. And now we have this user input, and we can just really quickly test if it's working. Come on. Oopsie. I had a little bit of lag right there. I'm going to clear it, and we'll just run Python, but we're looking for 3 test.py. And internet is slow right now. What did I call it? Oh, I did not call it untitled, did I? There we go. 3test.py. Did not work. Why not? Because it's a blank file. Okay, let's see if it works now. There we go. Now I got that program working, right? So really quickly copy pasted it, and I can see it has its original functionality. Now I'm going to take that and I'm going to slowly modify it so that it asks one question only once. So one easy way to do this is we can have a queue number. So question number, we can set it to 1. If the queue number equals 1, then we get that user input, but we ask for the question. Else, we'll just give it the standard prompt, right? And obviously, it's not useful if it always continuously prints it. So we also have to have on the receiving side, we don't want to have an empty prompt and it just says, your name is whatever's on that prompt. So we have to add on this side also some logic. So we'll do queue number equals 1, our conditional statement. And else, if it's not the first one, we'll just print whatever the input is, right? So we'll echo, in this case, the input. We can save that. And now if it's queue number, oops, this is wrong. This is definitely wrong. And actually, let's test it so you can see why it's wrong, right? Don't lag. So we'll do the 3test.py. We should expect it to only increment once, only ask the question once. And we find out it always asks the question, why? Thing is, I did not increment queue number 1. It is continuously on number 1. If it never changes, it can't update. So we need to update that queue number 1. Now it's going to increment that first time it hits. And now, if the program is done correctly, come on, keep interrupt. Now, if we run Python 3, it should only prompt it once, right? And it only prompts it once, and every other time it should just echo. Correct functionality. So now we have 3 steps. It's gotten a bit more complex, but we still haven't gotten our beautiful logic algorithm. So we want to kind of work it up a little more. So number 4, come on, save. And this is the downside of running things on the web. So part 4 is a little bit more interesting. I believe we're asking multiple questions. Come on. So this one, my name is Chris. My last name is Kopmeyer. And then it's just asking 2 questions. So how would we jump from a single question, right, to 2 questions? There's 2 questions. So let's just really quickly take our old code, because this is an iterative process. And then we're going to double click our editor. And this is the initial code we had. And to make this have 2 questions, maybe we want to say an else if condition. So from the last lecture, we mentioned an else if condition. And we might do something like that. And we could ask for a second raw input. So what is your first name? And what is your last name? Then maybe here, why do we need that update logic there? Maybe we just always update it. And then we'll just take here, we'll go queue number equals 2. We'll say your last name is, %s, and we'll do user input. Or alternatively, let's say that we wanted to have your first and last name. We could just remove this statement here, this if statement, make it if Q number equals 2, and then we could concatenate it, and you could say your name is Chris Kottmeyer when you give everything. Okay, I need to stop doing that. It's like I have an exit command. I build an exit command, and I'm so used to just stopping it using the keyboard interrupt. That's really bad. I should really, if I had that intention on the program, I should keep it that way. So Q4, we try it out. It runs perfectly fine. If I had an error, I would go fix it, and then we see if it actually works. So first name Chris, last name Kottmeyer, and then we get to that echoing portion of the code. And if we want to exit, instead of pressing Control-C, we just type exit, and just exit. All right. So I need to really quickly get a power cord because I'm getting too excited writing code and not paying attention to how itself. So far making sense, the kind of iterative process. And I kind of like showing this because you can kind of see how it works. You know, you test a few cases. I probably go through something very similar at work. So I'm at the moment for my work project, for example, I'm dealing with a backup system. So I'm constantly like shutting down computers, you know, making backups or making backups of databases while it's running. And so I'll use a similar process. I'll test a certain aspect of it, save the code, test the next aspect until I have something that actually runs. You might do the similar kind of work. You might do something similar with data analysis. You know, potentially, let's say you have a model that you've built, and you're building a lot of processing. You might iteratively process the data until you come up with something, or you might throw some code away and then start over on a specific step. So that's the fourth project. The fifth project gets a little more interesting. So we just keep upping the complexity a bit. So we can look at project 5 to get a sense of the behavior we want. Here we go. And then we do, your name is Chris. Your last name is, I'll use my last name. Did I already do project 5? So project 5 is interesting. This is what we called in the last time a refactor. So we take the same code and we're making it simpler to read. So we could go through this code real quick, and you know, you have your basic header up here. And then if you're looking at it, you have your Q number, and I put a default prompt. Just, you know, because it's easier, I have it up there, you can look at it. And then instead of having all of the output in the ending, what I did is I just have something called an in phrase. So that's the prompt number, what the prompt should be. And I might have something like an out phrase, which is like the output I want. So in this case, it's a little different. What I'm doing is I have all my questions input and the expected output in one spot. I could just add more questions as I go along. If I wanted to add a third or fourth question, it'd be pretty easy. I could just go up here, add another elif question. We could do Q number 3. And does anybody have an idea for a cool question we could ask myself? What is your hobby? Yeah, that's great. So like I'd have, what is your hobby here, right? No exclamation mark. There we go. And that would be like my prompt question, right? And then out phrase, I could just say something like, your hobby is %s, right? And the reason I don't have a variable there at the ending right now is I don't want to do that substitution of the keyword back in right off the bat. I want to wait to this very ending to put the user input in. So if I added that, you know, what it does is it goes through, it looks at the Q number. The first time it goes through, it asks about my name. It creates an in phrase, which is what the prompt is. We could call this the prompt variable. You know, out phrase would be your name is. it gets down to here. Now it's substituting the in phrase as a variable there, right? So that should say, what is your name? And as long as I don't type quit or exit, it comes here to the out phrase. And then I just do that variable, that %s substitution. I take the user input and put it into the out phrase. So that's a really easy way. I can add 100 questions. So if you decide you're doing a survey study, maybe a statistical survey study, you want to just have a program you send out, people fill it out, you know, you can just take the output and just send it to a file or something like that. And then, you know, it's you can kind of package it and send it out in a way. So if I did this correctly, which, you know, there's probably like a 50-50 shot of me not like key fudging it, I should have a third question instead of a second question. All right, so let's I modified that file, so since we're going a little bit of a different route, we can just grab this, post it into the file. Come on, post it. Hello, internet, wake up. And then we could just, you know, go back. We don't need that question. Keep the original code the same. There we go. So that was the initial code. I just Control-Z'd it all the way back to that initial state. And there's our modified code. So in our initial one, we just had 2 questions. Come on. Temperamental today. So in our initial version, what we end up having is, you know, what's your name, Chris? I put Kottmeyer, just goes to the prompt. And then what we can do for the next one, we go test pi. Oopsie, 5 test pi. Now we should get 3 questions. So Chris Kottmeyer, what's a good hobby? Board games. And your hobby is board games. So just by changing the way the code works, how it's structured, it makes it much easier just to start adding questions. And that makes it sense too. If we look at the previous code, we separated the input and the output as 2 separate operations. Here it's just very easy just to add a question. You just add this segment of code. You can just keep adding and adding and adding, and it's very easy to look up what code you have available. So project 6, I wanted to go a little bit more complicated than, like I said, this iterative process. We're making it more complicated. And this one, I think, is the one we start seeing more interesting behavior. We're going to show repetition. So it's at Python 5, oh, Python 6. So let's look at Python 6 a little bit. We'll execute it first. And clear. So Python 6 project, and there are only 9 projects, so this kind of gives you a sense of where it's how it slowly improves. So Python 6, what is your name? We start with Chris. Last name Kottmeyer, nothing new, right? And then name 5 colleagues. So this is a repetitive question. You're going to name 5 colleagues: John, Joe, Sarah, Mark, Kalyan. And then it ends up going straight to the prompt. So that's like a little bit more complicated. We want a while loop kind of inside of this prompt system. So we'll look at the code really quickly and kind of get a sense for modifications. So none of that really changes right off the bat. But what it gets interesting is I have a queue number here, and then inside this while loop, we have the current question, so I call it curQ, and I have a max QS, so max questions. So if I want a repetitive thing, maybe I'll start with 0, and I'll increment until I get to some maximum. So first question doesn't really change. If queue number 1 is 1, then you just prompt for the name. Queue number 2 is just the last name, so you're doing that same kind of prompt. Queue number 3 is interesting because now you have the name of 5 different colleagues, and we set this thing to max QS. And what I do is if the cur Q is less than max Q here, then I keep going until I get to the fifth one. So why does it work? So if I set the cur Q to 0, then when I get to that loop, I gotta look at it real quick. It's just going to ask me once, right? It's just going to do the while loop once. If I set it to 5, it's going to go through this segment 5 times. So let me point out because I think it's easier. So the first one is called the Q number, right? And that's going to tell me which of these 3 states I'm going to pick. So is it going to be the what is your name question? Is it going to be your last name question or the 5 colleagues question, right? If I get to this 5 colleagues question, I change this to max QS. So if it's any other case, it's going to be 1. The max amount of questions I'm going to ask is once. But if it's this question specifically, number 3, I'm going to ask it 5 times. What happens is when we get to this segment of code real quick, down here, we're going to ask for the input. If it's exit, we're just going to break out. Once we break out, if we don't break out, we're going to print it, and then we're going to increase the current Q limit by 1. Now, since it's set to 0 initially, on the top, right, we have 0. If it's any question but number 2, it's going to increase it to 1, and 1 is not less than 1, so it breaks out. So it's only going to do that loop once. But if this max QS is 5, it's going to ask it 5 full times. You guys see how that works? So I'll explain one other time. So it always starts, every single question starts with a number 0 and assumes that the maximum number of times you're going to ask it is once. But you can alter it in this question to extend it so that it goes multiple times. So if I wanted to ask last name more than 1 time, I could do max QS equals 3, and I could do max QS equals 2. And it should ask this one 2 times and this one 3 times. And it's just because it's manipulating how many times it stays in this loop. We'll do really quickly.
The thing with like the current question at once is gone through this one as a twice for the current question.
So this one and this one are independent of the Q number.
Okay.
So you can think of the Q number as kind of like it tells you which of these situations it's going to work in. So it's going to tell you the context is this one, the context is this one, whereas the context is this one.
So regardless of the max Q, it's not going to change here.
Yeah. Basically what it does is it, I will show you a good way of looking at a while loop is kind of go through it. The first time I say the Q number is 1, right? So when it comes in here, Q number is 1. At this point, like in the variable section I talked about, we're updating these values with per Q 0 and max QS 1, right? Q number is still 1. It hasn't changed yet. This first section only uses the Q number. So Q number is still 1. So it's going to go inside this loop. It picks up the phrase and the out phrase, the prompt and the output format. And then it looks at how many times we should iterate through it. So at this point, it used to be you only iterated through it once. But when you get to here, we update it to 2. So it's going to go 0 to 2 times. Because if statements, you only execute one of these 3 conditions, right? That was kind of part of the previous lecture. So it only picks up the context for this Q1. And I'll update it a little bit further. So it will skip everything else, and now we're in this while loop, right? And in this while loop, the curve value starts at 0, and the max value is based on this 2. So if we hadn't updated it, it would have just been 1. So the first time it loops up, this is 0, this is 2 right now. It asks for input, checks for an exit, and then breaks. If it doesn't, it prints the output, And now remember, it's still cur q is still 0. And max qs is 2, right? So after this update, this becomes 1. 1 is still less than 2. So then we go through one other iteration, asking for input, and then this becomes 2. Once it hits 2, this condition is no longer holds. So that's when it goes through, and then our Q number goes up 1. Now we're in the second condition. This time it's 3 times, so it goes through this loop 3 different times. Once it starts all over. Then when it hits that third question, right, it breaks out of it again. And then it continues to this last loop where it asks it 5 times. And then if we don't have a max QS, if we don't update this condition, the default is it only asks once. So this is just one implementation. There's different ways you can do this.
The curfew, is it you go back to 1 or go back to 0 or it's already 2?
So curfew, every time it restarts, it starts at 0. And then every time it starts at max QS 1. But then you can modify it conditionally with the branch. So we can let's really quickly test like my modifications. I'm going to add max QS equals, we could say 5 here, and we could do max, wow, that's asking for a lot of names, right? I'll ask the first name twice, the last name twice, and I can ask for 5 colleagues, 2 colleagues. And we can watch by just modifying those 3 parameters. We can see it should ask me every question twice now. Actually, that doesn't work if I, oh, okay, it is project 6. So what is your name? Chris, you don't accept it. Sam, twice, right? Now we're on that last name loop. Hotmeyer, Smith, I guess. Then we could ask for 5 colleagues, which in this case will actually be 2 colleagues because I forgot to update this. So we could do George. We'll do Kalyan again, and then it goes through 2 times. So just by modifying those 3 max JQS parameters, we are telling it how many times to actually process each question. So this is just showing you start getting even more complex behavior, and soon you know, a few more steps and you have the friendship algorithm that Sheldon talked about. And you can have more interesting, more dynamic stuff happening. So I think that was 6. Seven is interesting because we start getting something called linking. So I want to show you that because I told you about making those maps, right? You have to start linking questions to different questions, and that's where you start getting that behavior. So if we do project 7, who is your boss? My boss's name is actually Igor. Who reports to him? Chris. Who is your boss? Igor. It is a continuous loop, right? One question is mapped to the other question. So how would you do that? So if you go to part 7, you have queue number 1 here, and then queue number 2. Basically what I do is I reset the queue number based on what I want it to be. So in this case, if queue number 1 is asked, I set the queue number to 1, and when it adds 1 at the ending, when it adds 1 here, it's going to set it to 2. So we'll ask this question. If I have queue number 2, it resets it to 0. So when the loop starts over, it asks queue 1. You guys seeing that behavior? So if I have queue number 1, so yeah, I'll start with the queue number will start at 0. It adds 1 here, starts here, asks what my boss's name is, sets the queue number to 1. Next iteration, it will be 2. When it's a 2, it goes here and it asks who reports to him. Now it's setting that number back to 0. Next time it goes around, it's going to be 1 again. And because it's 1, it's going to ask who my boss is again. So you can route 2 questions between each other by changing the queue number that gets dealt with. Are you guys seeing the behavior? And if you can do it with 2 questions, you can link them back and forth. Who says you can't take those numbers and you can link them to other questions? And that's where we get our kind of last example. We're talking about linking questions. And this one, it's probably, I don't know, I was being kind of random with this. Sorry, MDs. So this is more like a yes or no game, right? So do you have a fever? Yes. Doctor says interesting. Do you have a cough? Yes. Do you want medicine? No. Are you sure you look sick? No, I'm not sure. Don't you want medicine? Okay, fine. Yes, I want medicine. I can give you an extra dose. No. Are you sure you look sick? What? Why is he not like giving up on me? No, I'm not sure. Yes, I want medicine. Fine, I'll take the extra dose. That will be $500. No. Are you sure you're sick? For $500? Yes, I'm pretty sure I'm not sick. So now you get these like interesting behaviors happening where you can start linking questions to each other. And you do that by having that queue number there. And you can redirect it by just saying, if it's on question 2, make the queue number 4. If it's question 4, make queue number 2 again. If you answer it a certain way, change the queue number. If you answer it another way, change the queue number. And that's very quick. We remember, we were talking about that friendship map. I'm just going to blow it up real quick. You got that bizarre behavior. Place a phone call. Home. Yes, go one way. No, go another way. If it's yes, then you might go here. If this one is no, then you go back to home. You can just change the direction of the logic.
Like go to.
Yeah, it's similar. It's bizarrely go-to-ish, right? But it's actually just all in a while loop.
Right. But it's like go to.
Yeah. It's similar to a go-to. So I'll show you guys the code real quick so that you can see this last example. So you can see the more like bizarre behavior that comes from this. So in this case, we have our queue numbers, and I decided to use different groupings. So the first 2 questions might be Q1, Q2. I might set this to 10 and 11, 100 and 101. I can then expand a certain section if I wanted to, or you could just do Q1, 2, 3, 4, 5, 6. And if I have an answer is yes, then I might forward it to question 10. If it's no, I forward it to question 2. Now I could just set up all of the different routing for each question. And then if I want to exit, I just set one of these to exit. So I set up my routing per question. And then because I'm kind of lazy, I always set the out phrase to interesting. So the doctor's, no matter what happens, the doctor's always going to say interesting. Because I'm lazy and I don't want to make it custom. But if you wanted to make it more custom or make him argumentative, you can add as much out phrases as you want, or output formats as you want. You have your user input being brought in here. If it's exit or quit, we exit. And then here's kind of more of the logic. If it is, if it's not exit, we subtract 1. Let me see a little bit. So if YQ is equal to exit, we'll just exit. If the user input is yes, I'm looking. So here's what we do is basically I test if the user input is yes. If it is yes, and the YQ, the link is exit, then I'll tell it to break. That's what's happening there. And then based on this, if I type in yes as the input, I decide to go through the YQ routing. If I put no, it's the NQ routing. If it's incorrect, I just go back. Yeah, I think. Okay, so sorry, I had to go. I wrote this like a few days ago, so kind of looking through the logic a bit. So basically what it does is you can write yes or no as a question. And if it's not yes or no, it just goes back to the same question over and over again. Because usually if the Q number increments 1, I don't want it just to keep incrementing. If I put some invalid input, I just want it to stay on the same Q number. And then if I have a valid input, which is a yes or no, right? Then I'm going to take the Y Q if it's yes, and the no Q if it's no. And that's based on that linking, right? So if I type yes for this one, it's going to take 10. If I type no, it's going to take 2 here. Does that make sense? And then if the YQ is exit and I put yes, then I'm just going to exit out. If the user input is no and the NQ is exit, then I'm just going to break out of it. Does that make sense? So that's just the 9 different steps of how you would act, the kind of 9 different steps, and you can kind of work through each step and make a more complicated prompt. Yeah. And then the third one I'm not going to be able to get to tonight, but I will go do like a small overview of it real quick. I'll show you guys the end result, and then if you guys are that curious, you can go through the code itself. So application 3 is definitely much more complicated. So I will go here. I will go back one application. I will go to application 3, and let me double check the cool looking one. The one that's kind of more interesting. So this one's interesting. This is the last project for the data processing one. And this file has Alice in Wonderland. Look how long it's going to take. So this is all of Alice in Wonderland text. Here's the whole text of Frankenstein. And then this is Kafka's Metamorphosis, and that's all sitting in the repository. And the code is basically going to look through application 3. It's going to find all the .data files. Then it's going to ask me a question. Do I want to process this file? And then the logic behind it is it takes this entire thing, it breaks it into words, it then counts, does a word count of this, and then it will create a summary file with word counts. And the summary file itself is not super complicated. I just printed out a counter object. So it's not very well formatted, but it's just more to show it. So we can do Python. It's going to be project 9, which is the most complicated one. And evidently, and we'll show you real quick. So do you want to process the Frankenstein data set? So you press yes, check the contests, press any key. That's the Frankenstein data set. Create all the words as a separate word dictionary. Those are all the words. So now we have all the words. We take the text, turn it into a list of a bunch of words. Then we do counts. So if you look at it, there's a counter function we use. You can see that this isn't a very clean one, but situations equals 1. So there's 1 count of situations. There's no stemming or anything. This is very basic. And I can't scroll any higher, but if you scrolled high enough, you'd get more interesting counts. And then the top 10 most words are right there. So again, there's no stemmer or anything here. So it's just the blank spaces, need some data cleaning, and of I to my a in that. Obviously very, your basic words that you always see over and over again. And if you wanted to, you'd write it to a file. We have our summary data. Wake up. Well, I guess in this case, I just wrote the entire dictionary out or something like that. Or maybe it's still opening. That could be a problem too. Okay, so that's probably a little bit of a bug. but it should print just to save this top 10 listing, basically. And then we could do that with the Kafka data set. So there's Kafka's Metamorphosis. And oops, I need to put yes in. I process it. I do the words. I do the word counts. I get the top 10. And then I save that file. And then if I put no, it just skips it. But if I wanted to process the last one, I could do yes too, and it's just the same process again. So if you're interested in that last one, you want to do more kind of data analytics is more your thing, that one's probably a good one to do. This is in the advanced section. So there's two problem sets that are more advanced. This one is one of the two more advanced ones. Yes. So for anybody in the class, as usual, I always have a survey at the ending. So if I really like surveys. So it's very simple. It's just how do you rate the class? Was it 1 to 5? How could it be improved? Any comments? I'm very looking forward to this because this format for this class was a little different this time because it was application based. Usually it's lecture based. So any other comments if you want to put down, I like the application style, or I prefer lectures, or I think it's good. The survey?
Yeah.
Seconds.
But can you please take the survey right now, please, folks, so that we can improve next time?
Yeah.
Also, let's go to your Slack so that we can tell them where it is.
Yes. So if you go to chriskottmeyer.com, the classes, and there's an eternal forever living link here. That's a Slack channel. You click it, and you get this channel, and then you can talk to classmates here. You can ask questions. You can look at cool Python projects. So there's Django, Flask, Pandas for data analysis, NumPy. All the source code is there if you want to look at it. You want to talk about GitHub, make an introduction. That's all available. And then I've had some students actually ping me on here and be like, based on the previous lecture, what exactly does that mean? So you can always ping me. It usually might take me a day or two, but I typically respond on the Slack channel. And you can always sign up through the Chris Kottmeyer website. There's a link to that.
We'll read them too.
Oh, the survey?
And the Slack.
Yeah.
Let me know if anyone needs help reaching this number.
Should be on the presentation. It's the last slide.
On the page, please. One last favor I want to ask you. Click that.
There we go.
Click this class.
This one?
Yeah.
At the bottom, I'm assuming, or?
Read more? Yeah. So another thing what I wanted to go about, efficiency, go about?
I think it might be a copy-paste work from a previous class.
Yeah, the one is going to previous one?
Yep, I can do that. So it'd be meetups past. This one, I'm guessing?
Sure.
Code blocks sounds probably right.
Read more?
At the very bottom.
Yeah, there's a Google survey. And yeah, this one. Did you see this in the, paste?
Oh, here?
Yeah.
You want me
Paste
to?
that in the, current thing.
Yeah, here it is.
Yeah, I want people to go there and provide a survey. Provide
What should I do? Write a review?
So we'll show people how to do that.
And you could just give a 5-star review.
Yeah, thank
You know, and you could put down great class or
you. Great, yes.
something like that and just post.
Yes. So one last thing we want you to do is go to our just type Health Innovators in Google, and you should see Health Innovators Meetup, and just type Health Innovators in Google and just rate us on Google. However you think, if you think we added value to you, please give us 5 stars. If you have any concerns, we can chat about it, and we'll see how we can add more value. So this is very important because people check us out before they come here. So if you see good stars, they'll just more likely to come here.
I have them planned. We might want to deal with timing though. Could do probably, would 1 to 3 work on Saturdays? Do you guys feel comfortable with 1 to 3?
It's up to you.
Yeah. So, well, I'm just asking generically, like a generic question is 1 to 3 sound. 6 to 8 sounds more like, bar time for me. So I want to grab some beers. Yeah, it's a copy paste thing. I copy pasted the Monday event from 6 to 8 over and didn't realize didn't change the 6 to 8 p.m. part. So I was thinking next class is 1 to 3, and I believe I already put it up there under meetup.com, right?
Yeah, just click on that meetup right there.
Health Innovator. So I actually set up all of the classes because I did that copy paste error, and I was like, I don't want a copy paste error problem because I showed up here at like 10:30.
This morning?
Yeah.
Oh.
Remember how I typed here?
Yeah.
Because I didn't realize I did a copy paste error. So upcoming. So I'm going to change the date to 1 to 3 just for now. But the next one is December 2. Ignore the 10:30 a.m. one.
December 2? We might have a conflict. We have a chatbot challenge that day.
Oh, okay. So not December 2, but probably close to December 2.
Yeah. When is the chatbot? Let's see.
Yeah, it's on December 2.
Oh, yeah, it is December 2.
Yeah. We can host it the next week.
Yeah, we could do something like that.
Yeah.
Okay, so we'll change this, but you can see all of them here. These are not stable right now because conflicts and stuff like that. We still have to go through them, but it's all the sessions are listed. I've kind of came up with a curriculum, so there's 10 of these lessons planned. We're right now on 4. Next one is number 5, so that's the 50% mark. And there should be, I have it set unless you guys don't like the application format. It should be 4 application classes and 3 application classes and 3 kind of lecture style classes.
So why don't you show your website so that people can get a whole view of the whole classes?
Yep. So real quick, we'll go through the classes.
So please go to Chris Cartemeyer and the classes. All the classes are here, and all the information is here.
Yep. And then these are the 6 segments, and the next one is going to be lists, dictionaries, for loops, dictionary and list comprehensions, and I might cover generators because I like the topic. Every one of these bullet points from 4 to 6 is going to have an application class afterwards. So you'll have list sticks as a theoretical lecture, then you're going to end up using them for cool projects like we just did, and then we'll do one on functions and importing functions, and the last one's going to be really kind of the high-level advanced classes, kind of classes, objects, inheritance, all those fun things, object-oriented program type stuff.
Great. So one last reminder, ladies and gentlemen, is December 2nd is the Chatbot Challenge, and it's a great opportunity to build just the chatbot, what Chris showed. We can actually build that thing, and we will have close to, right now, close to 70 people have signed up, so it's going to be a big showing, and we will break teams, and we'll have a challenge, and we'll pick the winner at the end of the day. And the other thing I wanted to talk to you about, this is on December 2nd, and it's a challenge, and it's going to be on the 4th floor. And the other one I wanted to talk to you about is on December 5th, we are having a pitch competition. We have 10 doctors as judges. And if you or anyone you know is working on a startup, please send your pitches to us. This is your opportunity to work with doctors. They could be your customers, or they could be your investors, or they could be a mentor or advisor. So we are a startup incubator. We help people how to start startups. So please tell all your friends to come here. We are hosting the developer courses, classes, because ultimately we want you to build applications. That's our goal. We want you to solve real world problems. But we're teaching you so that you can get there. So that we're teaching you because we want to give you something to gain your trust. But ultimately, we want you to produce something. Okay, ladies and gentlemen? So with that being said, please give a big round of applause to Chris here. Fantastic teacher, and Chris works at Salesforce in the AI department. So talk to him about Salesforce. Yeah.
Yeah, I manage like all the data servers behind the AI platform.
Chris, Salesforce is huge. Well, thank you so much, and enjoy the rest of your evening, and stay warm. I'll see you next time.
All right, thank you.
I don't think we
Okay.